The second way to classify serial communication is based on the direction and simultaneity of data storage. This is synchronous serial communication. This is based on simultaneity and direction of data flow. The classification based on simultaneity and direction of data flow. So, we have two types of serial communications. One is called simplex and another is called duplex. In case of a simplex, the data transmission will be takes place in only one way. Data is transmitted in only one direction. So, what is the example of the simplex type of data transfer? So, example is from microcomputer to, so all the time I am calling as microcomputer, means the CPU of the microcomputer is microprocessor. So, this is basically microprocessor based computer. So, if you want to transmit to printer, this will take place through simplex, because only one direction. Printer cannot transfer the data to the microcomputer, but microcomputer only can transmit the data to printer. The second one is duplex. Duplex means data will be transmitted in both the directions. Both the directions. But again, in both the direction, if simultaneous data transfer takes place or at any time only one way is enabled, depends upon that. Again, we have two types of the duplex. One is called half duplex and full duplex. In case of half duplex, the data will be transmitted in only one way at a time. Data is transmitted only one way at a time. Whereas here data is transmitted both the ways simultaneously. So, the example of both half duplex as well as full duplex is computer to computer communication. This is microcomputer 1 and this is another microcomputer 2. So, we are going to transmit through serial line. This is serial line. in case of half duplex, only one single line is enough. So, this can have the microcomputer 1 can transmit the data to microcomputer 2 or 2 can transmit to 1, but at any time only one way will be enabled. So, in case of full duplex, there will be two communication, one is from computer 1 to computer 2, second one is from computer 2 to computer 1. So, there will be two wires. This is example of full duplex. So, these are these different classifications of serial communications. So, one classification is based on synchronous or asynchronous, whether the clock is common or clocks are different, and second classification is based on the direction and simultaneity of data flow. So, the next topic that we have to discuss before going for the programmable communication interface is parity. So, normally in data communication what happens is, if you want to transmit the data from one computer to another computer, this is microcomputer 1 to microcomputer 2. Suppose if I want to transmit 3 bits of the data in half duplex, so there will be 3 lines, this will transmit 1 bit, this will transmit another bit, this will transmit another bit. So, we can have total 8 combinations of the bits that can be transmitted from computer 1 to computer 2. Now, during the transmission, the errors may be encountered. So, in such cases, how to detect and how to correct the errors at the receiver? This will act as now transmitter, this will act as receiver, and this will be the channel. This is channel, here is a telephone lines. I will discuss how the data can be transmitted over telephone lines from one computer to another computer. The channel is wide line. So, we know that in any communication system, the common phenomena is in the channel there will be some, due to noise, there will be some distortion or there will be some errors. But in digital communication, the error will change bit 0 to bit 1 or bit 1 to bit 0. Now, the question is how to detect and correct the errors at the receiver. For that, we have to add an extra bit at the transmitter, which is called parity bit, such that the overall information can have either even parity or odd parity. Suppose if you have 3 message signals, say M1, M2 or M0, M1, M2. So, what I will do is, at the transmitter, instead of transmitting this message signal, this M2, M1, M0 is message signal. Message signal is, this is actual the information signal is M2, M1, M0. M2 is MSB, M0 is LSB. So, in addition to these 3 bits, I will add one more bit, which is called as parity bit. So, this is parity generator. Here I have to go design a parity generator. Whose inputs are these 3 bits, message bits. And there will be one output, which is called as parity bit P. So, we can design this parity generator for either even parity or odd parity. Suppose I want to design for even parity generator, I will call this bit as PE. If I want to design for odd parity, I will call as PO. So, how to design this? Basically, this parity generator you might have studied in your digital electronics course. So, I will just briefly explain the design of this parity generator. So, we have M2, M1, M0 is message input to parity generator. Then output of this parity generator will be PE if I want to generate even parity. So, the logic here is, so whatever the combination of this M2, M1, M0, I have to generate PE such that these 4 bits, the 4 bits along with PE should have even parity. So, a number is said to be having even parity if it contains even number of ones. So, if I want to transmit 0, 0, 0 information, what is the actual parity in the message bits? So, how many number of ones are there? 0 number of ones. So, 0 is a even number. This 0, 0, 0 is already having even parity. So, I will choose this parity bit as 0 such that these 4 bits will be having now even parity. The second combination is 0, 0, 1. If I want to transmit without this PE, this is having odd parity. If I want to make this as even parity, I have to make this as 1. Similarly, 0, 1, 0 odd parity is there, you have to make 1. 0, 1, 1 even parity, you have to make 0. 1, 0, 0 odd parity means you have to add 1. 1, 0, 1 even parity 0. 1, 1, 0 is also even parity 0. 1, 1, 1 is odd parity, you have to add 1. The expression for PE will be now the Boolean expression. Wherever this 1 is there, you read the corresponding min term. This is M2 is 0 means M2 bar, M1 bar, M0 plus this one M2 bar, M1, M0 bar plus this one M2, M1 bar, M0 bar plus this one is. So, if I simplify this, we can put in the form of this M2 bar is common in the first 2 terms. So, the remaining term is M0 exclusive OR with M1, and between these two if I take M2 as common, this is exclusive OR which is complement of exclusive OR, M0 M1 exclusive OR, this is exclusive OR symbol, OR symbol. So, this will be now whole bar, because we know that M0 exclusive OR M1 is M0 M1 bar plus M0 bar M1. If you take the complement of this one, M0 complement of M1 bar, this is equal to M0 M1 bar plus M0 bar M1 whole complement. According to De Morgan's law, this is equal to M0 bar plus M1 into M0 plus M1 bar. So, M0 M0 bar becomes 0. So, we will get this is equal to M0 M1 bar in plus M0 M1. So, this is again exclusive OR between this, and exclusive OR operation will be having both associative property and distributive property. So, we can write this one as M0 exclusive OR M1 exclusive OR M2. No bracket is required because of the associative and distributive property of exclusive OR gate. So, the circuitry inside this even parity generator is this, basically 3 exclusive OR gates. So, this is PE, this is M0 M1 M2. So, this circuitry will be available inside this parity generator. Now, at the receiver we have to check for the errors. So, I will receive at the receiver, we have to design a parity checker, because at the transmitter I have generated even parity, you have to design here even parity checker, even parity checker. The inputs will be, because we are going to transmit 4 bits, so all these 4 bits will be inputs. Now output of this one will be, if I call E is equal to 1 means error, E is equal to 0 means no error. So here I will assume that at the most one error will occur. If more than one error occurs, we have the different techniques. So here for this simple technique, so I will assume that at the most one error occurs. So if one error occurs, if I receive here odd priority, so means there is a error. So E will be 1. So accordingly you can design the in a similar way the even priority checker. If I receive here even priority, no error, E should be 0. So you can design this even priority checker. This is a simple parity generator and checker circuit which will be used in data communication systems to detect the errors. Even you can correct also, if I go for the Hamming code, using the Hamming code we can detect as well as you can correct the errors. Yeah, this itself is error control code, is a course. And then we have checksum technique. So in the checksum technique what we will do is, we will add all the bytes of the data that is to be transferred. Then we will take the 2's complement of that data and we will transmit that 2's complement of the sum of all the bytes as the last byte. Then we will transmit. So at the receiver again we will sum all the bytes including the 2's complement of the earlier transmitter part. Then if we get that sum as 0 means no error, sum as 1 means error. That is some checksum technique. And we have cyclic prefix codes also. There are some convolution codes. So there are different techniques to detect and correct the errors. This is also another important concept in data communications. Okay. The next concept is how to transmit this digital data over telephone lines. We can transmit the digital data over the telephone lines. So what is required to transmit data communication over telephone lines? So what is required to transmit data over telephone lines? So we know that telephone lines are basically designed for transmitting the audio signals. Telephone lines are basically designed to transmit audio signals. What is the bandwidth of audio signals? Normally we will call as 20 to 20 kilohertz, but most of the practical signals will lies in range of 300 to 3300 hertz. This is called articulation range. So most of the audio frequencies lie in this range. But if I take this data bits, so what is the rise time of the data bits? Will be of the order of nanoseconds. What is meant by rise time? So this is transmission, this is logic 1 and this is logic 0. But this is ideal waveform, but practically this will take some time to change from 0 to 1 as well as 1 to 0. So this is the practical waveform. So the time taken to change from 0 to 90% of this final value, which is 5 volts. The time taken is, this is called rise time. So this is going to decide the bandwidth of the digital data transmission system. Okay. So this will be of the order of nanoseconds. So the bandwidth will be of the range of gigahertz. Then the question is how to transmit this large bandwidth signals over the small bandwidth telephone lines. So for that So, we need to convert the data bits into audio signals. So, we need to convert data bits into audio signals, audio tones or audio signals. So, the device which is going to convert this data bits into audio tones is called modem. Modem is a short form of modulator and demodulator. So, now the block diagram of the data communication system, where the channel will act as telephone lines, will be like this. So, we have a microcomputer. I want to transmit the data from one microcomputer to another computer, but I want to connect these through telephone lines. So, we know that the microcomputer is a parallel device. This will give parallel data, 8-bit or 16-bit depends upon the application. So, what is required is, as I have told, we require a parallel to serial converter. Now, the bit will be here, will be having zeros, ones in a sequence, sequentially. So, what is the circuit which converts this parallel to serial conversion or serial to parallel conversion? This can be implemented by using shift registers. You might have studied in your digital electronics. So, you can implement this parallel to serial conversion as well as serial to parallel conversion using shift registers. Now, you have got serial data, this is parallel data, and here we have got serial data. But what is the bandwidth of this serial data? As I have told, this is of the order of megahertz, but I want to transmit over the telephone line. I am going to connect only one transmission line. So, what is required is here modem. So, the output of the modem will be, so this will be audio signals. So, we have only two possibilities here, either we have to transmit logic 0, which is called as space, or you have to transmit logic 1, which is called as mark. So, we will use in case of frequency shift keying, there are different types of modulation schemes that can be employed in modem. If I use frequency shift keying, FSK, frequency shift keying. So, logic 0 space will be represented by one frequency, say F1, and logic 1 will be transmitted with another frequency F2. So, normally this will be 1070 Hz, 1270 Hz. Then the output of the modem will be, if I want to transmit, say, so this is a high frequency signal, this is low frequency signal. Suppose if I want to transmit 0, 1, 1, say 3 bits serially. So, 0 is correspond to one frequency 1070, which is low frequency signal. Frequency is low means time period will be more. This will be something like, this is logic 0. Then we have to send two ones. So, the frequency of this next two signals will be less. So, this will correspond to 0, this will correspond to 1, this will correspond to 1. So, this particular portion, this is correspond to 1070 Hz signal, which is low frequency, means time period will be more, and this signal is correspond to 1270 Hz signal, frequency is more, time period will be less. Now, this will be connected to another modem at the receiver. This is the transmitter part. From here to here is transmitter and this is channel. Channel will be telephone line. Because now the frequencies are in audio range, we can transmit over the telephone lines. Now from here to here is receiver. So in the receiver also will be having modem. So in the transmitter modulation will take place. So what type of the modulation we have used? Frequency shift keying. So the same signal will be received assuming that there are no errors, and here the corresponding demodulation will take place. So what will be output of modem? Ones and zeros. The input is this audio tones, output will be 0 1. Then this will be connected to serial to parallel converter. This parallel data will be given to the second microcomputer. This is about the complete system: transmitter, receiver, in between we have channel. We are going to transmit digital data over telephone lines. So because of this change different bandwidths, what we are going to do is we are going to use the modem to convert the data bits into audio signals, again audio signals into data bits. So in normally for low speed applications we will use FSK. We can also use some other techniques called as PSK, phase shift keying. For normally high speed applications we will use PSK. In PSK the phase of the signal will be changed. So logic 0 is as it is, we will transmit the signal. Logic 1 means we will make 180 degrees phase shift. This is logic 0, actual signal, and this is 180 degrees phase shift is there from here to here. This is logic 1. This is phase shift keying. Okay. So next one is we have QPSK. That depends upon the system. We have different types of this modulation schemes. So this is about the next topic, which is data transmission over the telephone lines. Now coming for the standards, serial IO or serial communication standards. So now to transmit the data from one computer to another computer. Okay. So different manufacturer will be having different computer configurations. Similarly, the peripherals. So if we take this microcomputers and peripherals. Microcomputers and peripherals will be manufactured by different industries. Different manufacturers. Now how to make compatibility? Suppose I want to connect a peripheral which is designed by some X company, and I have to connect to a microcomputer which is designed by some Y company. Okay. So for that you should have some common standard. If you have a common standard, this enables to connect one manufacturer's device with another manufacturer. So this common standard, this will enable the flexibility among various manufacturers. Now what are the standards in serial communication? So that we can connect this to the device manufactured by any company. Okay. So, there are basically two standards, one is current standard, another is voltage standard. Basically you have to transmit 1 or 0. Okay. So, in this two standards we have, one is current standard. In this logic 1 is transmitted by passing a current of the order of 20 milliamps or some 60 milliamps. Whereas logic 0, passage of current will be blocked. Because here we are going to transmit this logic 0 and logic 1 using current. The advantage of this type of current standard is, so this is less immune to the noise. The effect of noise will be less here. So that this can be used for long distance communications. Is suitable for long distance communication. On the other hand, we have the voltage standard also, which is the most important and most popular standard. It is called RS-232C interface. Here we will transmit the signal by means of voltage. So, normally the device will be constructed using TTL logic. Okay. So, if I take this transmitter, this is called data terminal equipment. Which is some sort of transmitter type. This is called DTE, such as microcomputer. So, we can have RS-232 interface. I will just show only 3 signals of RS-232 interface. The remaining signals you can refer to any data book. I will show the signal 2, signal 3 and signal 7. This is RS-232 interface. This is also corresponding 2, 3, 7. One is male connector, another is female connector. So, this will be transmits. This is transmit. This will be received by another terminal, which is called as data communication terminal. Data communication terminal called DC equipment, sorry, data communication equipment. Called DCE. This is receive. Okay. Similarly, this can transmit through this. This is transmit portion of, I will call transmit TX, and this can receive. This is full duplex. This is receive, and this is ground signal. This will be normally connected to the ground. The example of If this is microcomputer, example of DT is microcomputer, example of DCE can be a printer. In this case only one way communication. If this is also another microcomputer, we can have both the way communication. Now one important thing here is, so this data terminal equipment will send signals logic 0 and logic 1. 0.2 volts is corresponding to logic 0, 3.4 volts is corresponding to logic 1 in case of TTL logic family. So in TTL logic family, transistor logic, logic 0 will be represented by 0.2 volts and logic 1 will be represented by 3.4 volts. This is correspond to logic 0, this is correspond to logic 1. These are TTL levels. But RS-232C will not support TTL signals. So it have its own logic 0 and logic 1. So logic 0 is nothing but plus 9 volts and minus 9 volt is logic 1. This is logic 1, logic 0. These are the voltages supported by RS-232C. So in order to convert this TTL into RS-232C voltage levels, we can use a circuit called MC1488. This MC1488 converts TTL levels to RS-232C level. Similarly, the levels will be here now plus 9 volts, minus 9 volts, but again this DCE will operate at TTL levels. So here I want plus 9 volts is corresponding to 0.2 volts and minus 9 volts should be correspond to 3.4 volts. For that we will use another IC which is called as MC1489. This will convert the reverse operation, this will do the reverse operation. So MC1489 converts RS-232 C levels into TTL levels. This is how we can make the communication between, and this RS-232 having total nearly some 24 signals. I have not shown all the signals. 2 signal is transmit signal, 3 is receive signal, 7 is ground signal. So remaining signals I have not shown here. You can refer to any data book. So this is how we can make this common standard so that we can have the compatibility or flexibility among the various manufacturers. So these are all the basic concepts of data communications. So with this data communication concepts, we will go for the implementation of these data communications. We can do this implementation either using the hardware or software. Okay. So software controlled asynchronous serial communication. First I will discuss the software based, after that we will go to the hardware based serial communication, how to enable the serial communication using hardware. So in case of software, so we will use the microcomputer here. If I take data transmission, so we have the microcomputer or the microprocessor, and we are going to use accumulator. Or any other register. This is some register. I will take 8-bit register or 16-bit register, it is up to you. if I take 8-bit register, this will be having D0, D1, D2, D3, D4, D5, D6 and D7. So, the data that is to be transmitted on the serial line, I will first take into some register, because this register will contain parallel data. So, I will transmit bit by bit. First I will transmit D0 onto serial communication. So, I will have here output port, because we are going to transmit, we have to use output port. You can use 8255 output port. You can program one of the ports of 8255 as output port. This is output port. So, one of the pins of this output port we have to connect. Say if you want to connect to PA0, only one bit, because serial communication. Okay, this will be transmitted from here through PA0. Suppose if I want to transmit the 49H ASCII code, for that we have generated the waveform, one start bit, two stop bits. So, what is the waveform that is to be generated here and here? The same is here also. So, what type of waveform? Yesterday also we have discussed this one. So, one is one start bit, this is mark, without transmission the transmitter will remain at mark position. Then one bit position of low, which represents start bit. Then 49 will be 0 1 0 0 1 0 0 1. This is start bit. Then another 0. The first bit of 49H is also 0, 0, then 1 1, these are all of same duration, then 2 zeros, then again 1 1 for one duration, then 2 zeros, 1 1, then we have 2 stop bits. So, this is ASCII 49, up to here, and these two are stop bits. Total 11 bits we are going to transmit. This is logic start bit, this is 0, 1, 0, 0, 1, 0, 0, 1 is the total 49H. So, this will be transmitted on D0, but what we will take is first I will send the start bit, I can write the program also later. So, then this bit 0 first I have to transmit, you take into some register this data and you transmit the LSB bit position onto the port A, PA0, then you shift this data towards right, and then again you transmit onto PA0 and you set a counter, the number of bits to be transmitted. Okay. So, after this count is over, we have to stop this. So, this is about this counting operation. Then we have write bar signal, because this is writing operation, we need write bar signal. Then this output port will be having, we know that this will be having chip select signal, chip select bar, 8255 if you take as 8255 or anything. So, here this microprocessor will be having address bus, using this address bus using a decoder, address decoder, you can select the chip select. This is address decoder. This is about the data transmission block diagram. So, we can write the software program to transmit the data. Okay. For example, if I assume that the port A address is some 80H, 81 will be port B, 82 will be port C, 83 will be control word register. Okay. Suppose if I want to transmit the same thing. So, what is the program? First I will take move AL comma 80H. So, because this 80H will be control word register for making all the ports as port output ports in mode 0, because this is also 80H. To avoid the confusion, I will take this as F0H. F0H is the port address of port A. Then F3H will be control word register. So, out F3H comma AL, F3H comma AL. So, this will program all the ports as output ports, but of course, we are using only one port only. Okay. Now, I have to set the counter. Total how many bits I want to transmit? So, I want to transmit total 8 bits. I will take move CX comma 0008H. Then I will take this data that is to be transmitted 49H into some register, say AL, move, or I will take into BL comma 49H. First I want to transmit a start bit which is logic 0. So, for that I can take move AL comma 00H out, port A address is F0H comma AL. So, what happens to PA0? So, this all zeros will be transmitted, PA0 to PA7 becomes 0. So, thereby here 0 will be transmitted, that is this 0 bit will be transmitted, that is start bit. Then you have to transmit the first bit of BL onto the output port. Okay. So, for that what we will do is, I will take that BL contents onto AL contents, move AL comma BL, so that AL will be having 49H, rotate right AL by 0 1 bit, so that the contents of RL will becomes, first I will transmit as it is lower order bit onto the this port A PA0. So, I will just transmit this, later I will rotate. So, if I write this out F0H comma AL. So, what happens? Now, what happens here? I have taken here this 49H in AL. In AL I have 49H 0 1 1 0 1 0 0 1 0 0 1. So, I want to transmit first this 0 bit. So, this 0 bit means we have to take, otherwise you can take this data in the reverse order. If I take this data instead of 49H, if I take 94H, so I want to transmit this in this direction. If I take 94H 0 1 0 0, the first bit I will be transmitted will be this. Now, I will just shift these bits. So, I will rotate these bits ROL AL comma 0 1, then out onto this one. So, only one bit will be outputted. Now, DC decrement DC CX, or you can write directly loop, because CX you can use the loop instruction, loop up. So, this up will be, so you have to rotate 1 bit position. So, you have to rotate this by 1 bit position. You can write here that rotate instruction RO R or ROL AL comma 0 1 So, this up. So, that all the 8 bits will be after transmitting this 8 bit ASCII character, it will come out of the loop. Then you transmit 2 stop bits, move AL comma 00H out F0H comma AL, then again out F0H comma AL. In between I have to give delay, call delay. So, what should be this delay? If I want to use 1200 baud rate, yesterday we have computed the duration of each bit will be, this will be 1 by 1200, which is equal to 0.83 milliseconds. So, you have to write this delay program which is equivalent to 0.83 milliseconds. Even between 2 consecutive this bit positions also. So, you transmit here, after this rotate, here you have to call delay also, same call same delay of 0.83 milliseconds. So, that if I transmit first a 0 here, you call the delay for 0.83 milliseconds, so that it will end here, again you send 1, you call delay again. So, in every bit transmission we have to call the delay. So, likewise we can transmit all the 8 bits. This is about the data transmission using software, you can write the program. Similarly, you can receive the data also, data reception also you can do it by using software. That we will discuss in the next class. Thank you.